We are from At Home Tuition. In this video, we are going to see about rational numbers. What is a rational number? Any two integers that can be written in the form of a ratio, that is fraction, is a rational number. Any fraction with non-zero denominator is a rational number. We'll consider an example. Let a and b be a two integers. If you write the two integers as a divided by b with the condition that the denominator b should not be equal to 0, then you can call this ratio a by b as a rational number. We'll see some examples. So here 2 by 3 is a rational number, 4 by 5 is a rational number, negative 2 by 5 is a rational number, 0 is a rational number because it can be expressed as 0 by 1, that is in the form of a fraction. The negative 3 by 8 is a rational number. Again 3 is a rational number because it can be expressed as 3 by 1. Negative 1 is a rational number. It can be expressed as negative 1 divided by 1. So like this we have so many rational numbers. So from this example we can say that rational number is a type of a real number. That is, it may include a positive number, a negative number, that is a positive integer, a negative integer, a natural number, or a whole number. So we can say that rational number is a type of a real number. How to identify a rational numbers? Suppose if you are given with a number, and we'll see how to identify that number is a rational number or irrational number. So first you have to divide that given number into a decimal result. First you have to write that in the ratio form, then you have to divide that into the decimal form. So in this decimal form result we have three types. So first type is terminating decimal, that is, if you consider an example 3 divided by 2, the decimal result is 1.5, that is the decimal result ends. So you will call this as terminating decimal. Next, if you take negative 4 divided by 16, then the decimal result will be negative 0.25. Here the decimal ends. So it's a terminating decimal. Suppose if it's 5 by 8, then the result is 0.625. Here also the decimal ends. So it is a terminating decimal. So any fraction that gives the decimal result as terminating decimal, then you can say that fraction is a rational number. Next type is repeating decimal. So for example, if you take 2 by 3 as a number, if you divide, the decimal result will be 0.666, that is the 6 repeats. Suppose if you take 5 by 9, the result will be 0.555, here the decimal 5 repeats. So it's a repeating decimal. So if it is a repeating decimal, then you can say that the ratio 2 by 3 or the 5 by 9 is a rational number. You have another case. That is, if you divide 22 divided by 7, the decimal result will be 3.1415987, like that it goes on. So if you see this decimal result, it never repeats and also it never ends. So this type of decimal result, that is non-repeating and non-terminating decimal. So if you get this type of decimal result, then you call this 22 by 7 as an irrational number. Like that you have square root of 2 by 1, square root of 3 by 1. All these are called as irrational numbers. Next we'll check how 0 is a rational number. So 0 can be expressed as 0 by 1, 0 by 2, 0 by 3, like that it goes on. So the result will be 0. So 0 is expressed as a fraction 0 by 1 with the condition denominator is a non-zero number. So 0 is a rational number. But in the reverse case, you cannot write 1 by 0, 2 by 0 and 3 by 0 because if you divide, you will get infinite values. So 1 by 0, 2 by 0 is not a rational number. So we have the condition that denominator should not be equal to 0. We'll summarize what is a rational number now. So rational number is a number that can be expressed in the form of a fraction or ratio. So it may be a positive number, negative number, or a 0. So if that fraction is a non-zero denominator, then you can say that fraction as a rational number. So if you divide, the result should be a terminating decimal or a repeating decimal. Then only you can say that fraction as a rational number. If you get non-terminating or non-repeating decimal, then that fraction is a irrational number. Now we'll see the properties of rational numbers. The first property of rational number is closure property. So we have to see the closure property for all the basic operations. So the first basic operation is addition. So we are going to see the closure property of addition. For any two rational numbers, say a and b, a plus b should be also a rational number. So we'll see. So that is, if they are given with two rational numbers a and b, if you add that rational number, the result should also be a rational number. Then you can say that closure property of addition for rational numbers is closed or satisfied. So we'll see with this an example. So now we are considered two integer given two rational numbers, a, that is negative 8 over 3, and b, 5 over 6. So now we are going to add these two rational numbers a plus b. So negative 8 over 3 plus 5 over 6. Since the denominators are different, we are going to make it as a common denominator. So the first case, I am multiplying this with 3, the numerator and the denominator. So the result is negative 16 over 6 plus 5 over 6. So now the denominators are same. So you can take the LCM, common denominator, as 6, and you can add the numerators. So negative 16 plus 5. So the result will be negative 11 divided by 6, or negative 1 over 5. So if you divide negative 11 by 6, you will get the result as 1.833. That is the 3 repeats. So it's a repeating decimal. So the addition is also a rational number. The result is also a rational number. Next we'll see another example. The given rational number a is 1 by 4 and b is 1 by 2. Now we'll check closure property of addition for these two rational numbers. So a plus b equal to 1 by 4 plus 1 by 2. So again we are making the denominator common. So I've multiplied this with 2 in the numerator and 2 in the denominator. So 1 by 4 plus 2 by 4. So the denominator is common. So I am adding the numerator. So it's 3 by 4. The result is 0.75. Here the terminating decimal, the decimal ends. So this is a rational number. So from these examples, we can conclude that if you add any two rational numbers, the result will also be a rational number. So we can say that rational numbers are closed under addition. The second property is closure property of subtraction. For any two rational numbers a and b, a minus b should also be a rational number. So we'll consider two rational numbers a, that is negative 4 1 over 7, and b negative 6 over 7. So to check the closure property of subtraction, we have to subtract these two rational numbers. So I am subtracting a minus b. So negative 4 1 over 7 minus 6 over 7. So now first I am converting this mixed number to a rational number. So it's 29 over 7. So this negative and negative will become positive. So plus 6 over 7. So now the denominators are same. So I am adding the numerator. So negative 29 plus 6, that's negative 23 over 7. If I get the decimal result, I will get 3.2857. 142857142. That is the decimal repeats. So it's a repeating decimal. So a minus b is also a rational number. So next example, I am taking a as 4 3 over 4 and b as negative 3 2 over 4. First I am converting, that is 4 3 over 4 and 3 2 over 4 to a rational number. So I am getting 19 over 4 and 14 over 4. So I am getting the subtraction property. So now I am subtracting the numerator, 19 minus 14, that is 5 over 4. The result is 1.25. It's a terminating decimal. So it is also a rational number. So from these examples, I am concluding that rational numbers are closed under subtraction. That is, if you subtract two rational numbers, then the result will also be a rational number. So the subtraction property is also satisfied. The third property is closure property of multiplication. For any two rational numbers a and b, a multiplied by b should also be a rational number. So now we'll see with this an example. So I am taking the rational number a as negative 5 by 6 and b as 2 by 3. Now I am going to check the closure property of multiplication. So I am multiplying a and b. So negative 5 over 6 multiplied with 2 over 3. So I am multiplying the numerator and denominator separately. So negative 5 times 2 divided by 6 times 3. It's negative 10 over 18. So if I divide this, I'll get the decimal as 0.555. So it is a repeating decimal. We already know that repeating decimal is a rational number. I'll check with some other example. If I take A as 3 over 4 and B as 0 over 2, so here 0 is expressed as 0 over 2, which is also a 0. So now I am checking the multiplication property. A times B equals 3 over 4 times 5 over 2. So multiplying numerator and denominator separately. 3 times 0 divided by 4 times 2. So it's 0 over 2 is 0. So 0 is a rational number. So we can say that rational numbers are closed under multiplication. That is, if you multiply two numbers, the result is also a rational number. The next property is closure property of division. For any two rational numbers A and B, A divided by B should also be a rational number. So now we'll check this property with some examples. So consider two rational numbers, say A as 3 by 4 and B as 2 by 5. So now I am dividing these two numbers, A divided by B. That is 3 divided by 4 divided by 2 divided by 5. So 3 divided by 4. So the division I can represent it as inverse multiplication. So multiply 5 by 2. So now 3 times 5 divided by 4 times 2, that is 15 over 8. So if I get a decimal result as 1.875, that is a terminating decimal. So it is a rational number. Now we will see with some other example. So next number I am taking the example as A as 1/2 and B as 0 by 4. Now I am checking with this A divided by B. That is 1 by 2 divided by 0 by 4. So now I am inverse multiplying. So 1 by 2 times 4 by 0. So now if I multiplied 1 times 4 divided by 2 times 0, that is 4 divided by 0, it's undefined. So this is not a rational number. So with this one example, we can conclude that the rational numbers are not closed under division. So now we'll summarize the closure property for rational numbers. So for addition, the closure property is satisfied. For subtraction, also the closure property is satisfied. Multiplication is also satisfied. For division, it is not satisfied. So if you get 0 in the denominator, then it's not a rational number. So for division alone, the closure property is not satisfied. Thank you for watching the video.